Hello, I'm Ashley Congs, North American Sustainability Leader for Dow Polyurethanes. And on behalf of my colleagues, I'd like to thank you for the opportunity to present to you on the Renuva Mattress Recycling Program. The foundation of our efforts in sustainable innovation are the Dow 2025 Sustainability Goals. Renuva is focused on contributing to the second and third goals, delivering breakthrough innovations and advancing a circular economy, and represents a breakthrough innovation in the development of a circular economy for polyurethane foams. In 2020, Dow introduced a set of targets focusing on driving greater action around the issues of climate protection, circularity, and safer materials. With the announcements of new targets, we are accelerating our sustainability journey to address these current challenges. Our products and technology are critical to addressing the urgent issues of climate change and plastic waste. These long-term targets align to build upon our 2025 sustainability goals. New targets are aimed at carbon reduction and eliminating plastic waste. And with the launch of these new targets, we have an opportunity to drive meaningful progress, and to do so by collaborating with our value chain and industry partners, governments, NGOs, communities, and other stakeholders. In Europe, plans are in place to achieve a 40% carbon footprint reduction in Holland and Germany by 2030. Our Protect the Climate target is our commitment to implement and advance technologies to manufacture products using fewer resources and help consumers reach their sustainability goals and reduce their carbon footprints. By 2030, Dow will reduce its net annual carbon emissions by 5 million metric tons, or 15% from its 2020 baseline. Additionally, Dow intends to be carbon neutral by 2050 in alignment with the Paris Climate Agreement. How will we get to carbon neutrality by 2050? First, we will ensure that our products are more sustainable than alternatives. Many Dow products lower customers' emissions more than the carbon emission used to produce them. And we will build on this expertise and work with customers to create sustainable alternatives. In our own manufacturing operations, we'll build on the progress we've made to date by optimizing current manufacturing assets, implementing transitional technologies, and innovating next-generation technologies for emissions-free manufacturing. Leveraging our 125 years of manufacturing experience, we will work to innovate step-change technology for the 2030-2050 timeline. Finally, we're collaborating with stakeholders to incentivize low-carbon technologies, including collaborating with academics, NGOs, auditing experts, technology partners, and others to ensure that companies are able to account for GHG reductions through low-carbon products and technologies to incentivize low-carbon innovations that can reduce GHGs in society. As a polyurethanes business, Dow Polyurethanes is looking to unlock polyurethanes' full sustainability potential by addressing sustainability along the whole product lifecycle. Renuva involves several elements in this diagram. Certainly, it achieves a circular economy, but it also involves the supply chain and sourcing sustainable feedstocks. One of the key waste management issues for the polyurethanes industry is mattress waste. Currently, there are only two methods of disposal commonly available. The first is mechanical recycling, which is well established, but which struggles with issues surrounding legacy chemicals found in older foams, and is ultimately a process of downcycling, where something valuable, like a mattress, is broken down into something less valuable, like carpet underlayment. End-of-life waste, on the other hand, also struggles with the issues of legacy chemicals and REACH compliance, and is also requires a higher investment and operating costs due to the bulky and heavy nature of mattresses and the difficulty in disposing of them in landfills or incineration. The Renuva Mattress Recycling Program in Europe is a project which aims to contribute towards recycling end-of-life polyurethane mattresses in collaboration with value chain partners. The goal of this project is to implement the first industrial-scale reactor for such a chemical recycling process, in which polyurethane foams are converted from end-of-life waste mattresses back to polyol, which is one of the main chemical building blocks of the urethane polymer. This recycled polyol will then be used as a high-value component of the new PU foam formulations in different applications, such as flexible foams to produce new mattresses or in rigid foams for thermal insulation. As such, the program tries to address the enormous waste issue we have, where in Europe alone, more than 30 million mattresses are discarded every year. Mattresses make sense as a focus of action for a few reasons, but mainly because they're very bulky and take up so much space in landfills and require difficult handling processes to get to incineration or landfilling facilities. Driving forces surrounding changing the way that we approach mattress recycling involve new EPR schemes in several EU countries, which create the need to significantly reduce the use of landfilling and incineration in favor of recycling. The Waste Directive on an EU level mandates a minimum of 65% of municipal waste to be recycled in 2030, which mattresses would be a huge part of. Renuva is helping to address a current waste issue. Chemical recycling converts polymeric waste materials by changing their structure into substances or mixtures that are capable of being used as raw materials to produce new products, excluding energy recovery. There are several benefits of chemical recycling. First, it has an immediate impact on the balance. The foam breakdown on a molecular level eliminates the need for additional cleaning. Multiple end uses are possible besides consumer comfort foam, and the segregation of PU foam is not required. So how are we collaborating for success? As mentioned before, a circular economy for polyurethanes can only be achieved with strong collaborations and partnerships along the value chain. The chemical industry needs to facilitate the shift to a circular economy with innovation and new chemical recycling processes. Dow has already partnered in 2017 with H&S Anglo-Technic, a German engineering company, to develop a market for post-consumer PU recycling. And more recently, we've announced that this concept is becoming a reality. Yet even companies like Dow need to admit that the shift to a circular economy is not happening at the scale we're used to and are equipped to support. Therefore, Dow has also collaborated with OCO, who is an independent French chemical company who will operate the chemical recycling process on behalf of Dow as an external contract manufacturer. Dow then supplies other raw materials, ensures polyol compliance and fit for application, and creates the market and demand for recycled material. The key to success of this project and this ecosystem is to have a supply of the raw materials, waste, the end-of-life foam in our case, provided by Ecomobilier in France, and also the players in the value chain who will formulate new products with the new polyols. In this example, the Vita Group. So how is this done? It is a combined acidolysis glycolysis process performed in a batch reactor in which the polyurethane foam is decomposed and converted into a novel single product. The concept was originally designed by our partner H&S. The process takes up to 50% of end-of-life foam, which ideally needs to be dry and free of contaminants or non-PU foam materials such as metal, wood, fabric, and latex foam. The process is run at high temperatures, up to 230 degrees Celsius, under a nitrogen atmosphere, and the process yield is very high at about 75%. But what actually happens during the chemical recycling process? Well, a lot. There are many different reactions ongoing at the same time, competing with each other, which would take too much time to cover in this single presentation. What we did want to show here are the main decomposition mechanisms of the urethane polymer. On the left side, the reaction with a carboxylic acid is shown. It highlights that we can get the original polyol back, which was used during the production of the end-of-life foam. This is depicted by the rest groups highlighted in blue. What happens with R1 as shown here can obviously also happen on the other side of the molecule with R3. The rest group highlighted with the red dot is the aromatic group from the isocyanate, which as you can see, remains part of the new polyol as well. This is also valid for the reaction of the foam with a polyol or glycol depicted on the right-hand side of the slide, where the rest groups are highlighted again with different colored dots. The result of this reaction is also that the aromatic group from the isocyanate remains in the polyol and the original polyol can be liberated out of the urethane. Here we have diagrams of secondary PU decomposition pathways, pyrolysis and hydrolysis. Pyrolysis will begin to occur at elevated temperatures, and hydrolysis reactions occur due to water present in recycled foams. Both of these pathways lead to undesired byproducts that must be closely monitored during PU decomposition. What results from the process is a single liquid polyol, which contains up to 50% recycled content. The end-of-life foam coming into the process needs to be relatively pure, as mentioned earlier, but the PU foam itself does not need any pre-sorting whatsoever. The process is robust enough to take any type of PU foam, including conventional, HR, and memory or viscoelastic foams. As was previously mentioned in the presentation, Renuva polyol can be tailored for many different types of application. We have validated the technology in a truly circular concept, including using it in a flexible foam formulation, where we have replaced up to 30% of standard reference polyols. We have also validated Renuva for use in rigid foams, where we have replaced up to 50% of the reference polyol successfully. And the reference polyol in this case is a polyester type polyol commonly used in PIR rigid foam formulations. In both cases, we obtained very comparable results in terms of foam properties. We are also looking into the use of Renuva polyols in other applications through an ongoing evaluation process. Last but certainly not least, the technology has a very positive impact on environmental properties, including reducing the carbon footprint significantly. To sum it up, the Renuva program is addressing the mattress waste problem we have today by removing 200,000 mattresses every year from incineration or landfill. It is also a demonstration that polyurethanes can be recycled and that recovered polyols have value on the market. Finally, Renuva is an excellent example of how a circular economy can be achieved for polyurethanes with strong collaborations and partnerships across the value chain, and thus enable consumers to select more sustainable and comfortable mattresses. Thank you so much for your time and attention today, and special acknowledgement to the members of our team who have helped to pull this presentation together, including Lucy Porcelli and the Dow Polyurethanes R&D team, Will Kuntz, Matthias Schaefer, and Andrea Benvenuti.